Hi everybody, welcome to today's webinar. We'll get stuck into this in a couple of minutes whilst we see some other people arrive. Hopefully you're all doing well wherever you are in the world listening to us today. You can see I'm working from home, as have many of us for the last year or so. So I hope you're all doing well. I hope you're looking forward to today's conversation. It should be really interesting chatting with Ashley from Hariba Myra, and hopefully you'll be really interested in what we have to tell you in terms of the indoor facility and the indoor positioning system that we have delivered. We are recording this webinar, so it will be available on demand afterwards. There will also be time for questions at the end. We also have a couple of polls, just so we can get an idea of the audience. This main focus is going to be talking to you about the delivery of the indoor system to Myra, so those polls will come at the end. But hopefully we've left enough time to get through the content we have today, and then to kind of take an idea of who you are, why you're here, and also hopefully answer some of your questions. So hopefully now we've got a few more people. I'm going to kickstart this so that we can see the content and talk you through what we've been doing. So hopefully you can see my screen. We are introducing the indoor positioning at the UK's first automated valet parking test facility. This is that facility. So at Hariba Myra, this is the multi-storey car park, which OxTS has delivered an indoor solution for, a first of its kind for AVP and ADAS testing to look at as part of the assured CAV, which you'll hear a little bit more about in a second. And as part of this project and our delivery, there were some key things that Myra had requested that OxTS meet. So that's a better than 5 centimeter position accuracy, a 1 degree heading accuracy, and integration with AB Dynamics. We'll talk through some of the needs later on, but these are kind of some headline requirements. And we'll talk about a little why they were potentially a little bit difficult, how we met them, how we validated them. So you'll hear that throughout the session, as well as a little bit of what the future holds. So to do this, we partnered with POSIX, our new technology partner, where we had a really good mix of, or kind of shared culture, as well as best of breed technology. And so you will hopefully have seen that in January of this year, we formally announced this partnership with POSIX, an indoor positioning specialist with ultra wideband. And we kind of gave a sneak peek of what was to come. And this is essentially the first fruits of our labor. And we're really excited to share it with you today. And hopefully you'll be interested to hear more about what we're doing as we develop our technology further and our partnership further to deliver you an integration and a solution that really works for you. So first up, this is the multi-storey car park that we're in. So this is currently a single floor for the validation purposes and to start the scaling of the multi-storey car park. You can see top right, there's a floor plan. With our pre-sales support, this is something that POSIX will help you with in understanding the kind of idea of where your anchors should be positioned. And as you can see from the space itself, it's quite a compact car park. There's some metal beams creating line of sight. So it's not necessarily the most open and easy space, low ceilings. So it was a really nice challenge to deliver this for Myra. And you can see this was some of our engineers there chatting through as we did the setup phase. So in this webinar, we're going to cover the motivation behind the project in the first place. So why does it exist? Why did it come to OxTS to deliver for Myra? Why it matters for the industry. a little bit of detail behind the solution. We're not going to go heavy on technical details, but we'll try and find that nice balance between the layperson and some of the engineers on this call that will be interested to really know what's making this tick. We're also going to talk a little bit about the future developments, what else we're working on with Myra, and the kind of technology that we're working on. And then, as I mentioned, some Q&A at the end. Also, if you're just joining, we're also going to be including some polls in this just to get a gauge of the audience as well. Then general open forum for questions, where hopefully everybody on the panelist side will be able to join in and help you understand the solution further, or specific parts of the solution further. And then, as a reminder, this is being recorded. It will be on demand later on. If you've got a question at any time, do throw them into the chat on the right-hand side. We'll pick them up at the end, but please feel free to throw them in at any time. It'd be great to go straight into the questions when we come to the end. Okay, so that's all of the introduction, setting the scene. So now, just a quick introduction of who is on the call. I've already been talking for a while, but so my name's Peter Rylands. I'm product manager at OxTS, and the indoor positioning system is my product baby at this point within OxTS, working with everybody to come together for this best of breed integration. And I'm going to be the one taking you through the webinar today. We also have input from Johan and Charlie. Johan's our navigation manager and Charlie an engineer in his team. And they are essentially the brains of the outfit from OxTS. They'll be taking you through a little bit about how the system works, how we validated it, and will be again available for some of the more technical questions at the end. Then we have a couple of our colleagues from POSIX as well. We've got Alexander and Aziza online. Hopefully that will just be there in case you've got specific ultra wideband questions, so they can pick those up at the end as well. But we'll hear a little bit from Alexander in the webinar too about POSIX and why OxTS was a good fit for them too. And then the key man here, Ashley Patton, the lead CAV test engineer from Hariba Myra. So it would be great, Ashley, in this instance, we're going to be talking together a lot in this webinar about the solution. Could you give everybody an idea of who you are and what your day-to-day involves?
Yeah, thanks, Pete. So first of all, hi everyone, I'm Ashley Patton. So I lead essentially the physical connected autonomous and ADAS test team here at Hariba Myra. And physically today I'm actually at home, and I've been working on the development of the assured CAV facilities for several years now. We've been growing a significant ecosystem I'll talk a little bit more about, but essentially it's about us ensuring that we find solutions to the problems that our customers face. And the main set of requirements was to ensure that we've got a test vehicle and soft target measurement and control capability. But we'll talk more about the technical requirements in more detail later.
Awesome, thanks, Ashley. So now we're going to get into the meat of the webinar. So first up, again, this is going straight back to Ashley for a question here, which was, what was the driving force for this indoor positioning solution? Kind of give a sense of the context of why it's important for both yourselves and the market potentially. So why does this even exist as a solution requirement for yourself?
Sure, yeah. So the situation essentially is that the ADAS features and AVPS, automated valet parking systems, they're being development for fitment onto passenger vehicles, and there's a number of problems with that. So manufacturers, they need to ensure that the systems function correctly. So there could potentially be safety issues or issues that mean damage happens to property or the vehicles themselves. When I mean property, I mean maybe the infrastructures that they're driving in, like the multi-story car parks. But the big problem with that is that in turn could lead to damage of brand reputation, which in no doubt could lead to reduced vehicle sales. So on that, you know, if you think of some examples, there could be injury to pedestrians or significant insurance costs even. And we can resolve that by being able to validate automated parking systems and related ADAS features in the new assured CAV parking facility. So we see that essentially automated valet parking is a really exciting use case for autonomous functionality, and one where full autonomy within a specified area can be achieved in the relative short term. For that reason, it's key to our assured CAV ecosystem, and really important for us to integrate technology, which this enables to really replicate complex synchronized scenarios with soft actors, and really crucially for this project, there's a lack of GPS in the 3 covered floors that we've got in the multi-story car park. So accurate position data is really vital for being able to validate the performance of these systems. We didn't have a solution that could output position data in the absence of GNSS. So this project was just really about getting one.
Excellent, thank you. And you mentioned assured CAV there, and so again, it would be great for everybody to maybe understand a little bit more about assured CAV at Horiba Myra and the aim behind your ecosystem that you're building.
Yeah, sure. So assured CAV, it's a world-leading connected automated vehicle test ecosystem, and it extends over an 850-acre site at our Horiba Myra campus in Nuneaton in the Midlands. And assured CAV essentially provides the latest facilities, and what it does, it supports mobility companies in design, development and testing of self-driving technologies. The system itself, it provides a mix of physical, communication and simulation test beds, and that allow all-weather testing across a range of high-speed, urban and complex scenarios. And we do that controlled, semi-controlled and public environments. So our overarching aim with what assured CAV is to provide a location which helps mobility companies reducing uncertainty, complexity and time spent developing this technology. And we're doing that by providing the access to a mix of physical and virtual environments. And these replicate real world scenarios, allowing them to overcome the critical challenges of implementing connected self-driving technologies and ensuring their products are safe, secure and robust.
That's a nice link to the robust, because I know that's something that we particularly care about in delivering value, and that links to this question as well. And for everybody else, this is wanting to set the scene really for where the requirement comes from, and why with that requirement and the need for robustness and quality is why Datron Technology, the channel partner, the supplier that this was done through, and OxTS, why were we the ones that you chose to deliver this solution for you?
Okay, so it became apparent that a suitable off-the-shelf product didn't exist. So we turned to our trusted supplier OxTS and the channel partners, say Datron Technology, to discuss what we would do to approach a custom solution. To progress that forwards, it led to an initial scoping call with the OxTS R&D team, Johan and Charlie on the call today, and that scoping allowed them to understand our requirements and work first of all towards developing a viable proposal.
Excellent, and I think that's really key here. Is it was a really good challenge in the marketplace, and we started talking kind of September time, that this kind of came up as a requirement for you, and hopefully you'll see through this webinar how we solved that, the challenges that we kind of came across and the solutions that we had for those. And that all stems really from those initial requirements, something that was going to be challenging with time as well in this. So again, it'd be great to kind of talk about, this is very specifically delivering for Myra here and providing what you need. So can you give a synopsis, the reasoning why you've got these requirements as the key things for this project?
Yeah, absolutely, Pete. So essentially, we needed to be able to find that solution that could be used to develop, validate and verify automated valet parking systems. We needed to also think about park assist and other related systems as well. There are relevance because of the operational domain that they'd be working in. So, we're really particularly keen to focus on ensuring that robust performance with sort of low speed maneuvers, and most specific, to do with the small vehicle to target distances, and whether that's a target being a moving target or actually the infrastructure itself being the target. And kind of working through the list that we've got on screen now, obviously the first requirement naturally was for it to output position data, because we're in the point where we've got the absence of GNSS. So just to break that down a bit, obviously we've got a physical concrete and steel structure above, which is blocking the sight of the GNSS signals. So obviously we needed that. Due to the types of scenarios we would expect for this type of testing, we wanted a minimum of 5 centimeter positional accuracy and 1 degree heading accuracy, and up to speeds of 30 kilometers an hour was appropriate for the space. We needed it to provide full coverage, first of all, on one floor, which is around 650, 700 square meters. And that allows customers basically the maximum flexibility within the space because we've got full coverage. Integration with ABD dynamics, driving robots was really crucial for us to facilitate repeatable testing. We needed accurate path following, and really specifically synchronization was incredibly important with moving targets. We then needed to look at the solution to avoid making any infrastructure changes. The thing that's really important here is you've got to consider that if we start making significant changes to the infrastructure, what we didn't want to do is confuse relevant vehicle perception systems. So if we painted everything in a certain reflective surface that was now a challenge for radar or something, we really had to avoid that, because that really is the key feature of the facility being representative of a real world car park, and obviously that's the key feature of that. And we had a certain budget allocated, so we needed to make that as well.
Yeah, always the kicker at the end, and I think it was in the way in which it was first kind of put forward. The challenges that Ashley put forward to us at the time were, there are 2 main things that we need to know. It's one, where am I inside, and I need to integrate with AB Dynamics, and that we'd already done the harder bit, which was integrating with ABD. And so it's been great that we've been able to come through this, and we can now answer both of those challenges with confidence. And it's also worth mentioning at this time that OxTS have indoor technology already, and the issue was that it wasn't really fit for purpose for Myra. So for a long time we've had the reflective strip technology, and it provides everything that was required apart from avoiding the obvious infrastructure changes. This is aiding with retroreflective strips on the ground that are surveyed in, great for path following, really good at high speeds, and generally is very cost effective. But there's questions of kind of people dubious as to the impact it would have for car sensors, especially as those sensors, sensor development, autonomous vehicles becomes more and more important in the tool chain. And then we also have a integration with locator aiding. Now, this is a really expensive option, and while again it provided everything else that they needed, the budget being a really key thing here. Locators generally used for very large infrastructure builds, and so OxTS were obviously given a challenge here as well in terms of what technology we were going to be looking at, and that's something that we'll also now kind of going to be talking about. Is we needed to meet these project requirements. You're obviously here because we did, thankfully, and so the reason that we could do that was thanks to our engineering team and the way in which that they were able to deliver value through new technology. And the way in which that was achieved was ultra-wideband aiding. So with using ultra-wideband, we were able to meet all of these requirements for Myra. And this is where I'm going to bring in some of the OxTS engineers to talk a little bit more about the technology and how it works. So first up, I kind of want to pass over and ask, why ultra-wideband in the first place? And I think, Johan, you're going to talk to us a little bit about why ultra-wideband was the technology of choice.
Yes, hello everyone. So yeah, there are a few options when it comes to indoor navigation. Popular right now, SLAM techniques, which use LiDAR or cameras. Then they are possible options, but they are expensive, right? And we wanted something that's reliable, that does not use visual features, and is not influenced by changes in the environment, for example, other vehicles, right? And this is how we came to ultra-wideband and then chose the solution from our technology partner, POSIX. So ultra-wideband as a technique reached maturity as a positioning solution for industrial applications and is more accurate than other radio-based methods such as Wi-Fi and Bluetooth. Overall, the components of the INS, for example, antennas, are very similar to GNSS-based system. So I think the whole user experience coming from setting up the system, configuring the system, up to basically getting the data is very similar to that of a standard, basically RT using GNSS technology. And that's what we used in this case, ultra-wideband.
Brilliant, thanks, Johan. And then moving to Charlie, I think this one is, why did we choose POSIX? So obviously as part of this project, we've already mentioned Datron as the channel partner that OxTS work with, that essentially brought in this opportunity with Myra, and were able to essentially put forward why we were the right choice for them, alongside our ability to kind of talk through the confidence solutions. But we needed that technology, and we chose POSIX for that. So Charlie, I was wondering whether you could talk us through a little bit, why POSIX ultra-wideband?
Yeah, so I mean, internally within OxTS and the navigation team, we understand there's this need for other aiding sources in either in completely GNSS denied environments or harsh GNSS environments. And so we've been evaluating a number of technologies, including POSIX's, and when Myra came to us with this challenge, we were really deep in the process of evaluating actually the POSIX Creator Kit, which is a really nice kit that allows you to get down to the low level and really understand this technology. And when we started to discuss with POSIX how we can expand that technology into the Myra solution and move into the enterprise grade solution, what we saw there was the same level of performance, level of access to the data, and more importantly, actually that scalability going forwards as we want to expand Myra's solution.
Awesome. And I think also at this point, I'd probably like to bring in Alexander as well and talk about, in terms of the technology fit, I think it was immediate that it was going to be a really good solution, and also kind of maybe provenance that we were already looking at POSIX and your technology. But in terms of a strategic cultural partnership, Alexander, I was wondering whether you could talk a little bit about, from POSIX's side, why OxTS was also a good fit for you. This is where I hope he's found the unmute button. Okay, we might have lost Alexander there. From my point of view, for POSIX and OxTS, there was a real clear cultural fit. We both really care about the support that we can provide you in both pre and post-sale support, in terms of letting you understand what you need to know. And this also works with the channel partner network that OxTS has in the automotive world, specifically, that we can deliver great service from OxTS, from the channel, and we saw that POSIX did the same. There was a clear drive for providing this solution to the market, seeing the gap and wanting to fill it, and provide this best of breed solution where we could take two sets of experts and bring that technology together for a seamless integration, which should only get better. And the commitment from both parties in making this happen, and our ability to communicate as a team has worked really well, and we're really glad with where it's gone so far, and where hopefully it will go in the future. And also, obviously, for those online thinking about as a project itself, it's not just us delivering this technology, which you're obviously interested in and hearing about how indoor works, but there's also something to be said here for the way in which we worked in this project for Myra. Obviously, it's a client delivery project rather than just a general product delivery. And so, Ashley, again, from a person working with a large group, we had AB Dynamics involved as well providing their support. How was it working from your side with us in terms of communication, what other people might expect from working with us, that kind of thing?
Yeah, overall, I think the project's been made really significantly easier. The communication's been really good, and I think one of the big ones really is about clear documentation and openness. So, from our side, our time constraints have been really tight in reality, and our ability to commit massive amounts of time to this is also not necessarily impossible. So sort of clear documentation with system schematics, layouts, and early indications of performance when we're a bit early in the process and things has made everything just so much easier, to be honest. Yeah.
Excellent. I think that's I know that our team have really enjoyed getting involved, and also the POSIX team. And again, people like Aziza get really enjoying not only wanting to deliver it, but enjoying the project as well. And that communication, I think, is really key in terms of being able to kind of show where we're at, provide the updates where you need them, and having those experts on hand to kind of walk through what's happening, how we're validating, so that you can really trust in what you're being delivered at the end. OxTS's kind of tagline is measure with confidence. And so with this, we want to be able to provide a solution to the market that people can be confident in, and in this very specific instance, delivering to you so that you can be confident in what you're accepting and adopting within the multi-story car park for quite a large infrastructure of assured CAV. So now we're going to talk more into the technical detail. You've heard about the context, why we've been doing this project, why it was required for MIRA, the challenges and the requirements that we needed to meet. And now we're going to talk more about the actual things that make it tick. And this is going to be, again, back to the brains of the OxTS outfit. So it'd be great if Charlie and Jon, you could take us through the components that make up this solution for everybody on the call.
Yeah, so if we start with the anchor. So as Jon alluded to earlier, the ultra-wideband technology is kind of similar to GNSS in a way. So you can consider the anchors to be the replacement of satellites in this analogy. And so you can see in the floor plan at the bottom, we have a series of the anchors dispersed around the test area. And these anchors detect the ultra-wideband signals from the tags. In the installation process, these anchors are very accurately surveyed by us. And in fact, what we do to calculate the position, we use what's called a 2.5D position. Because if you imagine, unlike a satellite system where you have a nice hemisphere of satellites, you don't have the vertical distribution of these anchors in order to give you that accurate Z dimension. And so total in Hariba MIRA's installation, we have 9 of these, and we just use more anchors to get that extra level of precision out of the system. So I believe we're up to tags next. So continuing along with the kind of GNSS analogy, you can consider the tags to replace the GNSS antennas as you'd have in a normal setup. So they're similarly kind of placed on the roof of the test vehicle, and these transmit the pulses to the anchors. In the format of the technology we're using, these tags are able to retrieve the range data to each anchor on the tags themselves, as well as neatly from the POSIX side of things, they give us the coordinates directly, or the anchors directly on the tag as well. Which really just helps you determine the position of each tag. And so they are connected to our processing box. And so this is where a bit of the magic happens on our side. So processing box actually goes through the process of calculating the position from both of the tags, and actually also calculates the heading of the vehicle, which just enables static initialization, just like you would have from a dual antenna RT if you're using it outside. and then that processes the data into the generic aiding format, which we then pass on to the RT. So processing box is just connected via an Ethernet connection, and obviously then that goes to the RT in our generic aiding format, and that's where it's combined with our navigation engine to produce the accurate solution. And I think most importantly here is that after this point, there's nothing to really tell you that you're using ultra wideband. The user experience is exactly the same as if you're using GNSS, and the accuracy is very similar to if you had GNSS outside. And so by combining the data from the two POSIX tags as well as the IMU within our RT, we're able to achieve a more accurate solution than we would otherwise, and importantly, stick with that consistent 100 or 250 hertz output, depending on what's configured on the RT.
Excellent. Thanks, Charlie. And yeah, I think that's also been really important in that output from the RT. That's where the value in the ABD integration comes from as well, where essentially all of the outputs are the same. So integrations that currently exist should continue to work. We've validated the ABD integration at this point in time, but this one should hopefully also expand to other integrations that you have in place. Also, in terms of the hardware, we'll be continuing to develop these as well. So we know that we can work with POSIX, especially with tags. They're obviously not open, although the image was just to give you an idea of what's inside. So we'll also be continuing to see whether we can improve the hardware that's being used and the way in which it's being used to improve performance as we continue our development. And with that, so the work that Charlie and Johan did, we essentially were able to provide the Myra solution. See, there's one too many asterisks on that position accuracy, but essentially that one is there to say that it varies depending on the environment. As you saw before, the environment at Myra, it's a low ceiling. There's metal beams that can get in the way of line of sight of the anchors, and it's quite a small space. Then the heading accuracy, we managed that 1 degree as a minimum, and that was challenging because of the speed. So really low speeds, obviously, in terms of getting the heading, if we're going at the kind of 60 kilometers an hour, you'd see that it was the heading accuracy should improve there. So it was great that we could meet that challenge, and it's all kudos to the POSIX and OxTS team for making that happen. And as Charlie's mentioned, that data output rate stays the same. So 100 hertz or the optional 250 hertz on our RTs. The positioning technique that we're using is two-way ranging at this point in time. So this is the way in which we're interfacing with the ultra wideband. And we will continue to use this for the moment, but we're also looking into the time distance of arrival solution that POSIX have a lot of expertise in, and we're hoping that that can provide us more performance and flexibility in the solution and foundations of the use cases as we move forward. And that very clear challenge at the beginning, which we had in place to begin with and we needed to ensure we kept, was the integration with AB Dynamics, making sure that the positional accuracy was good enough that the UMAC status stayed at 9, so we could continue to provide that repeatable testing that Myra need with accurate path following using the driving robots. And also we came within budget, and that's also fantastic, and is also again one of those things that we were aware of for those in the market. So not just for Myra, but we've kind of been aware of both the position of the strips and the locator integration, also kind of being at two ends of the spectrum, and us needing to find something in the middle that can provide the value and the performance and the value for you to get what you need to do in the way in which you need it. So how did we prove it to Myra? So really important, again, measuring with confidence is really important, and the way in which we could validate the positioning, again, really important, so that Myra could be confident in what they were seeing and what they were going to continue to see as they use and adopt the system. And so, Johan, I think here you're going to talk a little bit about how we actually validated the performance for the system at Myra.
Mm-hmm. Yeah. So basically, we used 2 tests at Myra, both indoor, obviously. One based on static data, one to validate the dynamic performance, right? In the first test, basically we used a total station and we surveyed 2 points, 2 markers on the vehicle. By surveying 2 markers, we basically can evaluate both the position and the orientation of the vehicle. So we stopped the vehicle and surveyed it in different places and with different orientations, as you can see on the image on the left. And to work out the accuracy, we directly compared the surveyed position to the position that was basically calculated by the INS system. And we used the live data coming from the RT, right? The second evaluation method for dynamic data, so basically it's shown in the image on the right, right? So we used 2 markers placed on the ground, and we attached with a known distance, 3 meters in this case, between them, and we attached a laser sensor to the vehicle, right, to the car. Now, every time the car passed over those reflective strips, we basically recorded the exact time of the system, right? And after that, we analyzed the data. We analyzed the consistency of the positions over those strips, and we used we used a couple of times this set of 2 strips. So as you can see there, we used 2 different orientations, right? We repeated the test several times, both where the car was both driven by a person and by the ABD robot. And basically all these tests were very successful. The system was very reliable. As I said, we used the live data coming out of the system, and everything was within this limits or better.
Awesome, thank you. And then also, I think we've now got this little video, which we'll play and we can talk through as well. And Ashley, coming to you in terms of that validation process and seeing this on the day. So here you can see this reverse park with the SPT. Kind of 2 questions that would be great for you to elucidate on, which is how was the handover? What was it like seeing this working in action? And then also, what are we very specifically seeing here? And why is this a good representation of the delivery that OxTS provided in terms of an indoor solution?
Yeah, sure. So, you know, with the main thing that was really important to me was that I needed to be confident that the solution that we got was validated and that I was at least understanding the method that we've gone through to validate that, because of course we couldn't just use outdoor GNSS as an equivalent and do a back-to-back. That was maybe part of the development process, but in reality, when we get to the specific application indoors, using the IMU plus reflective strips was a really good way of doing that. And OxTS did think incredibly hard about how they would actually design the process of that validation and then demonstrate that to me. And you know, I'm pretty sure that the pressure is really on the team, because I was continually saying, I need to see it validated, I need to see it validated. And within that demonstration, you know, I got to see the objective data, and it was great. Overall, really impressed by the quality of the solution that OxTS has delivered here, and the requirements that we set were incredibly challenging. Not only did we want you know, the first application of an indoor positioning solution in such a complex space, but on top of that, you know, we've gone through some of the requirements earlier, but in terms of the integration with the ABD and you know, the time stamping for synchronization to allow us to do scenarios indoors was very important. And that really is exactly what we're watching in this video here. It's the interaction of accurate synchronization between the 2 objects. So just like we can do outdoors, we can use our synchronization system such that we can design it where you can have things always impact no matter what happens with the with the test vehicle, or we can allow it to be what we call smart actors. So it allows us to be able to plan behavior into, let's say, a pedestrian, and that means that with automated vehicles, it potentially can be a number of different outcomes based on what happens in the decision making of the test vehicle. But yeah, overall, it's a great demonstration to be able to show this video of the synchronization between the test vehicle and the pedestrian system there. Yeah, so really pleased with it.
Awesome, thank you, and nice that we could get this little shot of that working. So on from this one, if I can get along with the slides. So what's still to come? I think this is, we'll have a little bit of both here, so between myself and you, Ashley, here. But in terms of OxTS generally, we're continuing to work with Myra. There is more to come for this multi-story car park, and I guess in a synopsis, Ashley, what else is to come in this multi-story car park? What else are we going to be scaling for you?
Sure, yeah. So there is a phase 2 of the project, and essentially the next phases are that we've got coverage on the remaining 2 covered floors. So this is actually a 5-floor multi-story car park, and we've got 3 of them being indoors. Obviously, phase 1 has got 1 floor solution. Now we need the extension of that onto the remaining 2 floors. The floor-to-floor transitions are also included in the second phase, and also the outdoor to indoor and indoor to outdoor transitions. And we've also got 1 covered curved ramp as well, and we've also got a number of sloped internal ramps, and that will allow it to become not just the isolated singular floor, but the whole multi-story car park, because you can come in from outside Sky. You can kind of see on the graphic that's on the screen now, the entrance is over on the left-hand side of the screen. From there, you can navigate all the way up to the very top floor, essentially, and that indoor, outdoor, and outdoor, indoor transitions and the ramps and all the floors is obviously really critical for that. There's a few other use cases, but essentially, it's going to really further enhance the value that our customers can get from the facility. You know, and we really want to make sure that we can support them in cutting the uncertainty, complexity, and time from their development processes, and really add that value to them.
Excellent, yeah, and I think I guess to add from OxTS's point of view, again, in terms of delivering for a client, we were there to kind of validate that first phase, so there's the confidence to scale up, make sure that, you know, we can do what we say we can do. That's really important for us, and it also starts building the foundation generally for the market and you lot on the call that are interested in this, whether that's through Myra or through OxTS, to be able to get your own solution or test your own systems. And so, as we mentioned, we're talking about just validating the indoor-outdoor transitions, being able to validate the position over the ramps, especially in that curved ramp, which hopefully will be a nice challenge for us to do, given it's essentially an enclosed room in itself. And then generally from OxTS's point of view, it's looking at streamlining the solution. How can we improve the way in which we use the hardware? Thankfully, the POSIX anchors, we've got the IP65 rating, so making sure that we can also provide that same kind of robustness to the tags, and also then looking at ways in which we can kind of reduce the amount of hardware required, so that support is easier, that you can troubleshoot easier, that kind of thing. And we'll start looking at different use cases as well. So this is a great foundation of essentially validation for what's required and continuing to scale that up and validate as we go along. So hopefully you'll start seeing more iterative releases of validated value for the indoor solution. And again, just working with customers is what's allowing us to do that, because we're both helping you and also allowing us to give you the best service possible in validating your needs, because we know that environments are going to change. Not everyone's going to have this multi-story car park. Some of you will just be working in warehouses. Some of you will be working in longer tunnels. Some of you will be doing indoor-outdoor tunnel transitions. Some of you might just have denied GNSS environments. It might be that you're generally outdoors, but you have heavy tree canopies. you might be in mining infrastructure, that kind of thing. So there's a lot still to come from this, and it's going to be a really exciting rest of the year as we move forward to scale this up for Myra, and then also be able to provide that kind of value to you as we progress. So that's all of the content for now. There's a few things to finish up, and then we'll go to questions. I can see that we've had a few already. So thank you for listening so far. And if you're interested in the assured CAV ecosystem that Hariba Myra have, Ashley, how can they get involved?
Absolutely, yeah. So anything to do with the assured CAV ecosystem, yeah, the email's just on screen there, but it's assuredcav@hariba-myra.com. And if you want any direct conversation with me about the project or anything else in terms of maybe testing services overall, then you can contact me on, again, the email on the screen. It's ashley.patton@hariba-myra.com.
Awesome. And then from OxTS, if you're interested in your own indoor positioning solution, then get in touch with us. You can chat with info or sales at OxTS. Info generally if you want a little bit more information. Sales if you're there right now and you need to know more. So do get in touch with us, and we can work with POSIX. We will support you in pre-sale support, and we'll be there right through to the end, to delivery and beyond, to make sure that you're getting the value that you need and the performance you require. So we now have a couple of poll questions, or a few poll questions. This is to get some idea of the audience that you have so gratefully been listening so far. So hopefully you can all engage in these as well. And then after that, we'll be moving to the Q&A. So the first poll that we've got is, do you see an indoor testing requirement? And hopefully you will be able to see that on the screen. It says it's now collecting responses. So do you see an indoor testing requirement in your organization? And then you can see those on the screen. So yes, in varying time periods. No, you don't see it in your organization, or maybe you're not sure at this point in time. And I can see that everyone's getting involved here, so that's great. I think don't know whether there's maybe a few more to come in, but thank you for that. And it looks like there's a really nice spread of answers there. So I'm going to close that poll. And then the next one up, just so maybe I can share that information with you as well. So you can see that there's a real mix here. There's some of you that are just over a fifth of you need it in the next 3 months, and that's great to hear. So look forward to hearing from you, whether that's straight to OxTS or to Hariba Myra here for your requirements. And good to know that kind of the majority of you do see something in the coming months, year. So look forward to talking to you more about what we can do for you and how we can deliver that. So that's great. The next one is, how will you meet your indoor testing requirements? So this one again is a little bit more about, is this for your organization? Is this coming to OxTS? Or is it going to Myra? Or are you, again, not quite sure yet? Maybe it's a mix of both. And hopefully this can give a little bit of an idea of making sure that you're talking to the right people as well, post-webinar, that you're getting the information that you need. So getting your own indoor solution, outsourcing the requirement, probably a bit of both. And you might not have that testing requirement, or you might not be sure at this point in time. You kind of know that there's something on the horizon, but you're not there yet. A good amount. I think there's maybe a couple more. I've got half of you have voted so far, so that's great. Okay, and that's been up for a minute, so I'll now share those with you as well. So you can see just under a quarter of you looking for your own indoor solution, but then there is a mix where there will be outsourcing. Again, about a fifth of you outsourcing and a bit of both, and a lot of you that aren't sure. So for those of you that aren't sure, please do get in touch. Message info@oxts.com, and we can talk through with you what you're trying to do, when you might need it, and then maybe the best ways in which you can cover that requirement. So do get in touch. We'd love to hear more from you and support you through in your quest for indoor positioning. And then a final poll before we get to your questions, so thanks for bearing with, is what type of scenarios are you expecting to test indoors? You've heard here that we've been talking about kind of automated valet parking, park assist scenarios. It might just be APA, so automated park assist. You might be doing NCAP testing. Maybe it's vehicle dynamics in particular, so really high speed stuff indoors. Other, maybe it's you're not in the automotive space and you're looking to be tracking other things. Maybe it's automated robotic systems. Maybe it's positioning for mining equipment. And those of not sure, again, that I guess that'll link to those that maybe don't have a requirement at this time. And hopefully we'll get a few more votes in. Obviously multiple choice at this point in time, so there we go, and we're coming up to the minute again. So thanks to everybody there that has voted. I think we've had about 2/3 of you vote in all of that, and so I'll share this one as well. So a lot of you here looking at AVP and park assist scenarios, which is really good to see. Obviously we focus on this with Myra for their needs, but we did understand that there was potentially a need for that in the market too. So I'm glad that we've today been showing you something that is really relatable to the requirements that you have. In terms of your NCAP testing as well, I think we understand that there's definitely a need for that in kind of controlled environment testing. We've seen some of those use cases pop up in our conversations already. I'd be very interested to know a little bit more about the other ones as well. So for the 18% of you that said other, it would be fantastic if you could get in touch. Let us know what those other use cases are. Likely not automotive specific. So that would be great to hear from you. If you can spare a bit of time and send us an email and let us know. Again, we'd love to talk to you about it and how we can help you out. Okay. So hopefully you'll be able to see my screen again. And we're going to be going to questions now. So I think we do have quite a few, which is great. So let me just bring this up. Okay, so we have, how does this is from Annie Sala. I hope I pronounced your last name correctly. Annie, so how does the ABD SPT system get its GPS timestamp since it doesn't have an RT? Actually, that's probably one that you can pick up on this one.
Sure, yeah. So within the schematic of the indoor positioning system, the solution, there's also a GNSS repeater on each one of the floors. So there's just a GNSS essentially tag on the roof, then that goes through a splitter and then it's repeated over each one of the 3 floors. The only purpose for that is to get the timestamp. So that means that within the IPS system through the POSIX and the tags on the test vehicles, we can also take the same GNSS timestamp, which is essentially all the SPT system would get anyway when it was an open sky. The actual layout of all the SPT on the ground is always done from the positioning of the test vehicle, whether you've got a robot in there or just a motion pack. That is always used to define with the extremity polygon of the vehicle the referencing position in the coordinate frame. So that really reinforces with the SPT as well why the accuracy of the actual test vehicles is so important, because you're also using that to define where the SPT is.
Excellent, thank you. I see that covers hopefully a couple of others. I've seen a couple of others about time synchronization there as well, and it's essentially similar Then we have another question with characters, so I can't read out the name, but so asking about why 1 degree's accuracy is sufficient for a APA and AVP testing to Myra. So again, Ashley, probably one for you there.
Yeah, okay, so with this system, we have to still recognize that we work to the equivalency of what we might be able to get outdoors, and bear in mind that this is a new installation of a new application, and with the phase 2 we are going to be working to greater levels of accuracy with that. With the great value in terms of having the indoor localization is that we can automate scripts, and obviously with having the robotic control in there as well, that really adds the value in this, especially for things like smart actors. So you can see even from what we've got here, the overall accuracy, and maybe Johan could add a bit more about it, but it's greater, it's better than 5 centimeters accuracy, and a function of that also is the heading. And when we start looking at what we've done in terms of validating the system, you can see straight away from the example that we put on there with the pedestrian synchronization. In that mode, if anyone is familiar with full synchronization mode in Anti-the-Best Dynamic Synchro software, essentially the pedestrian system moves with relation in a speed ratio to what the test vehicle movement is. And in that situation, the repeatability was such that we always designed the scenario such that the sensor of the rear bumper of that test vehicle would impact the arm of the pedestrian. And with that, the accuracy there is proven that it's suitable for this application.
Awesome, thank you.
Yeah, because you mentioned that, I would just say that, yeah, actually in the tests that we've done, and I described before, especially in the types of repeatability, consistency, the position was close, actually much closer to 2 centimeters, the consistency of the position. Yeah, the heading in static conditions was more like half a degree. Mm-hmm.
Fantastic, thanks for that, Johan. Again, that's kind of, we're talking about what quite often something that OxTS do in terms of our delivery is we're not going to overpromise. So the things that you get told you can do, you will be able to repeatedly see when you do your work. And again, the kind of the space that we're in, hopefully you'll see better than kind of marketed numbers, and we can work with you to make sure that you can improve your performance as much as possible. So yeah, they're the kind of the minimum requirements that we needed, and hopefully there you can see that. And thanks, Johan, there for adding in that we can do better than that as well. Then we've got one from David Bromfield, which is, are the GPS pos mode signal enumerations the same when using this solution? And hopefully Charlie or Johan, you can answer that. So that's are the GPS pos mode signal enumerations the same when using this solution?
No, they're not the same. What is the same is basically the status that we use for synchronization with the ABD robot, right? So that status, which is 9 in very good conditions, and then 8 and 7. The position status is a new position status, right? And however, other variables such as uncertainties, position uncertainty, 2 centimeter, 3 centimeter, heading uncertainty, those are, just those values. So they're in the same sort of scale as the GNSS based systems. But no, the position status is not the same, and that will allow us in the future to basically mix GNSS data with ultra-wideband data, for example, and show to the user which one is used at a particular time.
Yeah, that's really good, and that's something that's really important for future development. Is this isn't a replacement for GNSS. Right now, we just don't have GNSS, so we're using ultra-wideband. But thanks to our generic aiding technology, something that's a real value from OxTS's hardware, and the firmware that we have. The generic aiding allows us to bring in other information to improve your performance, depending on the aiding source, depends on which performance it's going to improve. But in this instance, that's going to start to allow you to use IMU, GNSS, and potentially ultra wideband at the same time. Cool. So then one from Padraig, we've got, is there a plan to provide seamless indoor-outdoor transitions? Simple sentence to that is yes. So yes, the use case is valet parking. Again, part of the validation is the allowing Mira to see that we deliver on what we say we're going to deliver, and doing that in iterations. But so because we can use GNSS and ultra wideband together, we'll be working on validating those indoor-outdoor transitions, and that's just the thing that we need to do is do the validation work. The initial requirement here wasn't to have that in place. We're pretty sure that it's going to happen. It's just something that we've not validated at this time. It's part of phase 2, and it relates to the reference frames that are being used from indoor to outdoor. Then we have one from Brian Buss, which is what kind of anchor densities are needed for the 5 centimeter accuracy achieved? And this is maybe a good one for both us and POSIX here. So first off, hopefully if we've got either Aziza or Alexander from the POSIX team, you talk about 10 to 30 centimeter accuracy of a POSIX system on its own. So what kind of density do you suggest with the POSIX ultra wideband? And I'm hoping that Aziza or Alexander's there. Yeah, Alexander.
Can you hear me?
We can, yeah, welcome back.
Really? Okay, yeah. My apologies for the issues I had. Yeah, it's really depending from use case to use case. So each time we estimate the floor plan with some pictures and with some on-site visits to see where to position the anchors and how many anchors that we have to foresee. But on average, we say that every 10 to 15 meters we install an anchor, but sometimes it can be 20 and sometimes it can be 10. So it's really depending, and we take the time to offer for each project a personalized anchor plan.
Awesome, thank you. And yeah, I think that's really important is the environment thing. And I can see, Charlie, that you've popped up, so you got something to add there. And you muted yourself. That's on your dual mute.
Dual mute, 2 buttons.
There you go.
Safety feature. So the key thing is the number of simultaneous anchors, and so it really depends on the environment. You obviously see at the Mira car park, you have those pillars, because that's what really drove. Originally we went with 6 anchors, and what really drove it up to 9 was just ensuring we get that good line of sight, so between 4 and 6 anchors at all times, just to give that best position solution. So it really depends on your environment, and like Alexander said, and I think it's everyone's installation is going to be different, and the POSIX system is very flexible in terms of being able to add anchors in, or we can go and test and optimize the system to that specific environment.
Yeah, thanks, Charlie. And that's a kind of a nice segue on the kind of it per environment is the approximate cost of the system for this application. So in terms of again, essentially it varies depending on your environment, the cost, but it is essentially competitive for the market. It works on RT devices that we already have. So if you've got a V3, then you're good to go. You just need the feature codes and the processor. And then with the ultra wideband, we know that it's a cost-effective system. So it will scale depending on the size of your solution. But if you're going all in fresh from the start with this kind of application, kind of the same area with Hariba Mira, you're looking at kind of just over 100,000, somewhere between 100,000, probably 150. And that's to include 2 devices, like 2 RTs for 2 robots, the processors, feature codes, the anchors, tags, gateway, that's all going to be part of that cost, and some of the ancillary items as well. So, and as I say, that's from fresh. So if you've never interfaced with either of us before and you've not got any of our equipment, that's what you're looking at. And then obviously in these early phases, in terms of if you've got an exciting use case, then we can see whether that's something that actually aligns with where we want to take the product. And then also it means that we've got the options within OxTS for potential upgrades, or in talking the way in which that you're using your RT. So the approximate cost is going to vary, and we can take that on a case-by-case basis, and that's what the OxTS and the POSIX bit is for, which is helping you understand what you need, how much you need, and helping with that budgeting question, which normally comes before any specification turns up. So if you've got an environment that you want fill in, let us know, and we can provide approximate costs for the specific environment rather than just a general cost. Because I could also tell you that an approximate cost could be hundreds of thousands more, depend if it's an absolutely massive car park and you're using lots and lots of RTs. So totally dependent on the use case. But competitive, it is something that is definitely achievable and accessible for everybody, really. Then another one from Annie. So can the positions of the POSIX anchors be easily changed, or do they remain fixed once installed? I.e., can we easily install them inside different buildings? And I wonder, again, Charlie, I see you've popped up, so maybe you've got something there. And then also we'll get something from Alexander or Aziza there too. And say Alexander's come on. So Charlie, why don't you start there?
Yeah, so to get the best possible accuracy, they should be accurately surveyed. But the POSIX technology has a really nice self-survey feature where you still get pretty good results, but we couldn't guarantee absolute accuracy. So Alexander, I don't know if you want to elaborate.
Yeah, that's correct. So each time you install an anchor at a specific place, you have to measure the XYZ coordinates. So you can do it manually with a total station, but we also have an auto calibrate function that is working very fine. So imagine if you have a temporary setup where we have installed 10 anchors, for instance, and you have to move it to another site, then you can easily replace them. But then it's always interesting to keep us posted and to check and to prepare a new anchor plan, because it may differ from the other locations. We can advise you for the second location with a new personalized anchor plan, where you have to insert the new XYZ coordinates as well.
Excellent. And then generally, there's some Visa wall mounts that you can get. So if you want to, you can fix them to your infrastructure and have them as permanent installs. Technically, they're movable though. You just need to be resurveying them in place. So it would be as much effort again if you were moving them around. But technically, yes, they are portable. You could put them on some tripods or semi-permanent fixtures. It's just depending on what your setup is. Like if you've got lots and lots of anchors, you're going to be spending a lot of time resurveying if you're moving them around all the time. You might want to put in pre-positioned surveyed points if you're moving from space to space. So maybe you've got a multi-story car park and you've got a warehouse. Your testing is flexing between the two. You should probably understand exactly where those should be when you're doing semi-permanent install. But then if you really need a quick setup, then as Alexander and Charlie say, there's that quick configure essentially in the POSIX software, which is really nice.
It also has the ability to reload in previously. So you could, if you have those fixed points, you can easily kind of reload in those anchor coordinates once you've move them. You just need to make sure you use the same anchor ID in the same spot. But again, they've all got labels and stuff. But the POSIX interface is very easy. You know, when we originally started going to Mira, we used it on tripods, and that's how we've used it ourselves, and we had absolutely no problems resetting up the system.
Excellent, thank you. Then can ABD's GST be used? So I'll pick this one up. So if so, how? So at the moment, we haven't really got a very good solution for a GST. Because we have that processor on board, obviously the launchpad is made to be run over, and we know that there isn't really a suitable solution at this point in time for a GST, but we are definitely aware of that fact and want to try and come up with a solution that really works for the market and you, Annie, moving forward. And I can see Johan's popped up. I know that some of the stuff that we're working towards hopefully does provide us a good solution for it.
So
and
I think we have a good plan actually for this. So it's in the next stage actually it won't be really a problem in the next one of the next phases. Yeah.
I'll soundbite that one for next time. So yeah, that is on our roadmap. We're aware of the GST and the requirement, and we essentially want to make that happen. And so hopefully, yeah, you'll see that being released in conjunction with ABD as we move forward. But what that looks like is kind of being developed right now. So we won't say much more than that. Then we've got, I see a couple from Brian Buss. We've answered a couple of them. Brian, I don't know if you missed it. There was one about the simultaneous use of GPS and dual and ultra wideband for transitioning. And exactly, yes, that is what we will be doing when we validate that. And then I think that is all of the questions we have. If anyone does have any further questions, do throw them in now. We've got a little bit more time, I think, to talk through things with you. But generally, right now, I want to thank you all for joining. I'll keep the question tab open for a little bit longer in case some come through. But I want to thank you for engaging with the polls. And also for joining today. Hopefully you've seen that we've essentially delivered a really good indoor positioning solution for Mira. And if you're interested in getting it for yourselves, do get in touch and we can talk through how we can get you set up to bring your testing indoors. Continue to look out for more updates from us as well. As I say, this is in active development. We started this project back in October. Initial conversations were in September. So the fact that the team have worked really hard to deliver to the timelines for Mira and being able to provide that to market is fantastic. So hopefully you can continue to see that iterative development as we move forward and as we scale the Mira car park. If you're interested in the Assured Cab facility, do get in touch with Ashley or Hariba Mira. If you're interested in your own solution or want to hear more, do get in touch, info@OXTS or sales@OXTS if you're ready to buy right now. And essentially, yeah, thank you very much. Hopefully you've seen that we've produced a really good performing system that can work for you. You probably do have some more questions, so feel free to send them in whenever we need. Actually, we've just had one from Annie talking about the GNSS repeater and whether it can be turned off in a low GNSS environment. So in terms of, we don't use the GNSS, the satellite information other than time from the repeater. So you're essentially in a low GNSS environment anyway. The reason for that repeater is to allow time synchronicity, which is really important for the ABD robots. And if you're doing RT range as well between our vehicle-to-vehicle systems, that time synchronization is really important in being able to provide repeatable tests to a high level of performance and accuracy. So you would already be in a low GNSS environment there. So thank you everybody for joining. I think we'll leave it there. Remember, this was recorded and I believe will be made on demand for you after this, so you can share it around with people. Hopefully you've learned something today, and if you're interested generally in working with OxTS, for some of you that said that you don't have a need right now, maybe you have a need for something else, do get in touch. We love working with our clients and producing projects of value. So if you've got something else, then do let us know. Hopefully you've also learned a little bit about what working with OxTS is like. And thank you everybody on the panel as well. So Alexander, Aziza, I didn't get you involved, so you managed to stay quiet for this one. Maybe next time I'll call you out. Ashley, thank you very much for taking us through from Myra's point of view, for getting involved in today and for helping us throughout the development phase to make sure that we're towing the line for you and delivering what you need. And then also to Johan and Charlie for delving into a little bit of the technical detail. So it's thank you from me, and hopefully thank you from everybody else as well. Thank you for joining. And we will definitely be talking to you all soon. Look out for more webinars from OxTS. Look out for the press releases as we develop further. And make sure to check out the Harib and Myra website to learn more about Assured CAV. They're doing some really cool stuff and really valuable stuff for you, so you can definitely find some value there. And if you're interested in ultra-wideband, do check out POSIX, our new technology partner, and hopefully you can see that we're delivering really good service there. So thank you everybody for joining, and we will be talking to you soon.